All right, everyone, I've got the top of the hour. I want to welcome you all to this month's installment of the NCAT webinar series, From Research to Implementation. I'm excited about this week's topic because it was a big deal when I was in West Virginia and on the roadways there. It's reflective cracking. And so the use of asphalt interlayers to mitigate the reflective cracking is our topic today. We've got some great guests. I'm excited to get this going. So with us, as always, is Nathan Moore. He's the Assistant Director for the Test Track Research at the National Center for Asphalt Technology, where he helps lead the applied research in asphalt materials, pavement performance. He's also a licensed professional engineer with experience in balance mix design, pavement friction, and test track operations. He plays a key role in turning research into real-world results by helping evaluate what actually performs under traffic. Nathan's great at connecting the asphalt innovation with practical field performance and giving the industry answers that they can trust. Next, we have Tom Harmon, who's here with us at NCAT as well. Tom is a senior research engineer at NCAT, where he helps deliver asphalt training and leads research on asphalt materials, quality assurance, mix design, and other emerging technologies. Tom's a licensed engineer. He brings deep experience in both research and implementation from his experience with several different leadership roles with the Federal Highway Administration. He's widely respected for helping bridge the gap between technical innovation and practical application in the pavement industry. Tom understands both the science and the deployment side of asphalt technology, which makes his perspective especially valuable for people trying to move the theory into real-world results. And again, we have our guest and dear friend of ours, Phil Blankenship. Phil is the president of BAT Labs in Richmond, Kentucky, where he specializes in asphalt engineering, testing, training, product development. With his bachelor's and master's degrees from the University of Kentucky and decades of hands-on experience, he helps a wide range of partners tackle complex pavement material challenges. He's especially well known for his work in balanced mix design, pavement performance, and practical asphalt problem solving. He brings both technical depth and real-world experience into the conversation. Phil helps the asphalt industry bridge the gap between lab science and field results, which is exactly what we need to build longer-lasting, better-performing pavements. So it's great to have all of them. I do want to remind everybody, keep yourself muted. And if you have questions, please type them in the chat box right away. We'll address what we can there, and we'll do a Q&A at the end. Given that, Nathan.
Thank you, Travis. Our slides advancing.
Yep.
Very good. All right. Well, most of you on the webinar participating, you guys know the drill, but this is our standard format. I'm going to introduce the topic very briefly. I'll briefly describe the history at the NCAT test track, or the NCAT lab. And in today's case, it's the test track, and talk about lessons learned. Then I'll kick it over to Tom to talk about NCAT side, and then Phil. The question and answer will be at the end. However, these webinars are very, very helpful whenever you guys get your questions in the chat during the webinar. So as you think of it, go ahead and type it in. Sometimes if it's quick and easy, we're able to respond during the session. But sometimes it's good to also bring them up at the end just for an open panel discussion. So please, 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 as you have questions, don't hesitate to get them in the chat. With that being said, NCAT has a long history of testing interlayers at the test track. Typically, though, what we do, because we recycle our test sections, like the actual real estate where we test this stuff over and over to swap out experiments, sometimes we have to saw cut to simulate deep cracking or simulate concrete joints. In fact, in 2024, we did this for two test sections, one of them for the Arkansas DOT, where they were simulating concrete joints and poorly rubberized concrete joints, and another case with the Oklahoma DOT, where we were simulating block cracking. This is a pretty good technique. I think we've refined it over the years. I've been really pretty happy with what we've got now. So we have done specific interlayer studies, not just reflective cracking studies, for the Texas DOT in the mid 2000s, and then also twice for the Georgia DOT in 2012 and 2018. Texas used their thin overlay mix, that Tom mix, a really rich, fine mix as a thin overlay. I'm sorry, excuse me, as an interlayer in the mid 2000s with an extremely successful experiment. And Georgia, in 2012, they were looking at triple chip seals. I think it was triple chip seals versus open graded interlayers. And then in 2018, they had a wide variety of test sections, which I think Tom's actually going to talk about later. So I won't steal any of his thunder. Um, Moving forward, though, we are excited. There's some of you may have heard of our Next Pave Challenge, which we are looking as our large group experiment on the 2027 track, where we actually have a couple, actually, I want to say two or three different entries into the Next Pave Challenge technology ideas submitted from industry geared towards preventing or mitigating reflective cracking via the use of some form of interlayer. So we're really excited. I can't wait to cut more cracks into our track. Hopefully that gets to work out. Lessons learned over the years. One of the big things that we've learned, and I've also heard this in industry as well from a couple different sources, if you are going to do interlayers, specifically open graded interlayers, these are really good tools for preventing reflective cracking just because they're so flexible and they really arrest those cracks and kind of relax those strains. But you got to daylight them. You have to daylight these. When I say daylight, I mean you've got to drain them out the sides. If you don't, you are putting an open graded layer on top of a surface that's already has cracks. And so if you get any pumping or water seepage from the bottom, it has nowhere to go. And then you end up creating a bathtub. You have stripping potential in the aggregates that you use for the OGIs. You've sort of created a reservoir, but no way to drain it. So that's really, really important because not all there's a couple different options for interlayers, but if you do go with open graded interlayers, this is very important to daylight them. And also, whenever using multi-layer treatments, specifically double or triple chip seals, you got to be careful not to overdose emulsion content because you're stacking these treatments on top of one another. So a lot of times, some of the emulsion that the suppliers may have different recommendations for how to handle that because you don't want something that's too flexible and doesn't have enough structure sitting up in it. Lots of other lessons learned. I could talk a lot about saw cut cracking as well. I don't have a bullet point for it, but when you make your saw cuts, if you're in an environment like I am, in an accelerated pavement testing environment where you are trying to assess the impacts of these interlayers, you really have to make sure that those cuts don't have any load transfer between them. If you're trying to simulate a nasty crack or a joint, you've got to that moves. You have to make sure that you do that well. And so we've talked about that on some previous webinars. Good interlayer mixes don't necessarily make good surface mixes. And this is really important. And Texas used that Tom mix, and now that Tom mix is a good surface mix. But sometimes good interlayer mixes are extremely flexible and they don't always make good surface mixes. So these are targeted solutions to prevent reflective cracking. And I think it's a really good it's a good way to take care or to maybe do rehabilitation on a particular route cheaper in some cases. So with that, I'm going to stop sharing and I'm going to turn it over to Tom.
All right, looks great. Fantastic. So first, got to thank our sponsor on this one. Georgia DOT has been a sponsor of the test track many, many times. And I'm going to highlight work we did with them starting back in phase 5V of the test track, which was back in 2012. And then over a decade later, finishing up in 2024 with phase 8. So there's going to be 2 batches. Each one received 2 cycles of loading. So every cycle, 2 years, we put 10 million easels on a section. And whenever you're doing a cracking study, we've learned that 1 cycle is not enough. You really need to run 2. So 20 million easels in each one of these to go through it. So our goal here is how do we defeat these evil reflective cracks? And as the slide says, this can be our nemesis in a lot of ways because it eats away at our pavement. So the idea of putting in an interlayer, something that's going to isolate that crack from a leveling or surface course up top is what we're trying to achieve. And there's a wide range, as you're going to see in just a second in my talk and also with Phil, that you can do this as well. So for those who have been out at the test track, it's 1.7 miles of joy in Opelika, Alabama. And we're going to be looking at the northwestern portion. That's where the Georgia DOT sections are. They're affectionately known as N12 and N13. And as I go from one study to the next, you're going to see subsections appear. So back in the first round, back in phase 5 of the track, we went in and saw cut in cracks to reflect. So this was a full depth asphalt section, cut at 8-inch wide saw cuts, full depth. The intervals going longitudinally were every 3 feet and transversely every 15 feet. So if you assume about a 1 foot influence zone on that crack, about a third of the surface above is going to be influenced by those cracks and those joints moving as they're under traffic. So for round one, and this is in phase 5 and 6, we tried a double sand seal coat. It was a little over a 1/2 inch thick, and then an open graded interlayer, a little over an inch thick, was applied. After trafficking of 2 full cycles, we did see low cracking with the double sand seal coat, but more than a 1/2 inch of rutting, so 0.8 inches of rutting. So that one, not much cracking came up through, but you can see there was a rutting challenge with that mix. For the open graded interlayer, even though it had 50% cracking, so more than right around half the joints reflected up through, all of them were low severity, so they were under a 1/4 inch thick, and the rutting was around a 1/4 inch as well. So after the 2 cycles of this, we went in and milled off those sections, went ahead and cleaned out our man-made reflective cracks and resanded them back down. So for phase 7 and 8, starting in 2018 and running through 2024, we subdivided each section into 3. So a total of 6 treatments were applied. So in N12, which the trucks reach first, we started out with a geosynthetic that's called Glass Grid. The commercial version of this was CG100. And then we went to a Petromat. I'll show you some close-up pictures of this in a second. A fabric was applied. Our control was a virgin chip seal. It's a number 10 stone chip seal. And Georgia has used this throughout the state with some good success. For the other things that we looked at in section N13, we looked at a more sustainable chip seal using wrap. And tell you a lesson learned with that as we get to that section, followed by an asphalt rubber gap graded mix, and then an open graded interlayer again. So let's go ahead and walk down these interlayers as we were placing them down. So here's a photo of the glass grid product going down in the background, and in the foreground you can see the Petromat. The tack that was applied was a PG 6422. Full disclosure, if you go to Petromat and you place this down, their spec says we should use the PG 70, but as you'll see here towards the end, the 6422 worked just fine. The application rates were 0.3 and 0.27 gallons per square yard on the sections. Here we see our control, our virgin chip, and then the wrap chip seal in the background there. Both of them had the same tack, a CRS 2-hour at 0.24 gallons per square yard. Now that rate may be a little high for the wrap chip seal. We think it was because in the end we saw higher rutting in the wrap chip seal, and we didn't expect that because the wrap has already got some coating going on with it. If we were to do this again, we probably would reduce that tack rate. Here's the asphalt rubber gap graded. For this one, we use a trackless tack by Blackledge. It's called Ultra Fuse at 0.24 gallons per square yard. And you can see the section going down here. And then scooting up just a little bit further and looking down on it, this is the open graded interlayer. Again, using the trackless tack from Blackledge, the Ultra Fuse being placed at 0.25 gallons per square yard. Now, before I show you the next slide, everyone wants to know about ride, rutting, and cracking. Trying to get ride on short sections is a challenge, and Nathan and his team do an amazing job with that. But when you're talking about a third of a standard section, getting ride is even more challenging. And that's unfortunately what we found with our first section, which had the glass grid in it. So coming off of N11 onto N12, we had a rough N11, and it started us out pretty rough on the glass grid section. Over 150 inches per mile was recorded. And then you can see that that actually smoothed down a little bit with trafficking, where the rest of the sections started out between the 75 to 100 range and pretty much stayed in there. If we look at the change in IRI with regard to the loading, which was 20 million easels, we see here that the glass grid got a little smoother, and by and large, they all pretty much stayed in the same range, except for the wrap chip seal picked up 30 inches per mile. Again, that might be attributed to the higher tack relative to what it needed. Moving on to rutting. The only one that stood out here, as you can see, really no rutting at all for the first several million applications. And then we start seeing a little rutting kick up with the wrap chip seal. And that one actually gets close to the half inch, which we don't like to see. And the rest of them remain relatively low rutting. So let's go ahead and look at that side by side after 20 million easels. What we see here is that we've got 4 out of the 6 treatments, all were around a quarter inch or less. The wrap had the highest at 0.4, followed by the asphalt rubber gap graded. And I think that's because you get a lot of flexibility with that asphalt rubber. But this study is about cracking, because we're trying to stop that reflective cracking. So how much reflective cracking really did come through looking at these various treatments? Well, they look pretty good. We got an initial bump that occurred with the asphalt rubber gap graded after a full cycle and a half. So this is not starting at 0. This is at 15 million easels. A little over that, we got our first crack showing up in the asphalt rubber gap graded. And after 20 million, it finished out with only 3%. And that's pretty awesome. That's percent of lane cracking coming through. The rest of them held fast to almost 19 million easels, and then we saw a little cracking appear in both the open graded and the wrap chip seal, where they both finished out at about 1%, so 0.8. Looking pretty good. So now, as Ben Bowers likes to say, here's our favorite game. Can everyone find the crack in this picture? Remember I said this is the one this is the asphalt rubber gap graded. And if you look really, really closely and you squint and you have great internet connectivity and good eyesight, you'll see there's the crack. So even though the cracks did appear, they were relatively light in thickness, which was wonderful to see. So for these sections, let's sum them up, both the first round that we had in cycle 5 and cycle 6, as well as 7 and 8s. Here's a summary of all of them, looking at it from a cracking percentage. First of all, the first rounds did not do as well as the second rounds. We did see cracking and rutting in them. And then, but we see for the virgin chip, the Petromat, and the glass grid, no cracking at all. Just a little bit of cracking, and the asphalt rubber graded had it the most at only 3%. So 5 of the sections effectively mitigated reflecting cracking for a total loading over 4 years of 20 million easels, which is pretty amazing. So for our interlayer insights, as we go through these 2 rounds where we're trying to mitigate those man-made cracks up, For sustainable solutions, the wrap chip seal seemed to work as a viable alternative, although we would adjust the tack rate down, we believe, and that would address the issue with regard to rutting. For the reinforcement solutions, excellent. And the only thing I've heard anecdotally on this, don't let your first application of trying one of these concern you if you have trouble rolling them out and laying them down. If you're not familiar with it, it's a product you have to get used to. Please work with the manufacturers. They are there to support you on that. And then, a variety of approaches took on our nemesis. They showed that we got the maximum performance. We couldn't get the reflective cracking to come through even after 20 million. So with that, they have been validated by the Gauntlet, which is the trucks out at the Asphalt test track for NCAT. And I'm going to stop sharing and hand it over to my dear friend Phil.
Awesome. Thank you all. Well, again, thank you all for allowing me to be able to share this with you today. And I'm gonna go back a little bit. What we're gonna do here is we're gonna talk about the asphalt interlayer, and I'll give you a little preview with the camera before I jump into the PowerPoint. Something I've worked with since about 1998 is a product that we're going to be looking at today, and this is made at any hot mix plant using local materials. But as Nathan said, it's not meant to be a surface, but we've got something that we can take and it's pliable, we can bend it, and we've got a crack dampening system. And that's really what we want to think about today. This is a hydraulic mix similar to what you maybe have seen on bridges or Asphalt Institute deemed it as they call it hydraulic mixes because it's impermeable, but also one that you may see on landfills. Again, we're talking about the background, timeline, mix design, a little bit about site selection, and then a few projects, and we'll wrap this up. We know what reflective cracking is. This is one that I pulled off on the left from FHWA, where you begin to define the concrete, the existing problem, and what you're covering up. What I've seen through the years is that anytime you get into the official joints where you have the movement, that is what you're trying to work on. Most systems do a really good job at covering up the mid-slab cracks or corner cracks, but when you get into the jointed concrete where you have the load transfer, that's the problem, because you're now trying to delay the movement that's not just lateral, but it's the shear movement. And the shear movement was shown years ago to be the most difficult in studies that had been done by Mona Smith and others at Cal Berkeley. In the 90s, interlayers were used, or even before that in France. 1998, I was working at a company called Koch Materials Company. We brought it to the US naturally because it had a high polymer loading in it and it worked well for our business, but it also worked well for the business model to bring new products and try to innovate. Various levels of success because we have a much broader climate area than what you may have in areas such as France, from our far north to our desert areas to the deep south. 2002 through 2006, I actually got to work with Bill Butler on a National Science Foundation grant where they modeled accelerated loading and testing. There's a reference number if anyone wants to look at this. They developed abacus models and all these wonderful things for pavement design for the interlayer because nothing was out there that really described the interlayer well at the time. And the current pavement designs, there's nothing where you can flip a switch to introduce an interlayer into these pavement designs to do what it does. Out of this test is called the DCT that you may hear about today that's used up in Minnesota and FAA. It was actually developed out of this work as a test to measure this thinner roadway core properties that we were trying to measure back then. So this became a product that was developed and it began to work well. We began to focus on site review, thickness, and a performance-based spec. Back then, we were using a 4-point beam fatigue device and a beam stabilometer for rutting. We were trying to pick tests that we had in our laboratories that we could control the outcome a little bit more. We knew flexibility was key, and when I say a 4-point beam fatigue device, those that are out there in the technical world that love to run this test We're not talking about 200 microstrain, 800 microstrain. We're talking 2,000 microstrain requirement. So this unit, if not set up right, would about jump off your desktop with the level of movement. Moving on in the uh, into what we look at today, there's some 20 states that may have old specs in place. They already mentioned Texas that has their Tom mix. They use an overlay test. You'll see remnants of this original interlayer and if not the original, in Wisconsin, Iowa, Kansas, Kentucky still uses it, New Jersey, and you may see it with a fatigue spec. You may see it with other tests. And out of necessity, where I was not able to get always be able to get the polymers that was used back 20, 30 years ago, I had to come up with alternate ways and trying to use newer testing. And so while adoption slowed due to lack of understanding today, interlayers are still intact while the surface has been replaced, which has raised eyebrows that we need to go back and look at this product. For example, one was placed in Kentucky just north of me on I-75 with about 40 million easels. It was put down in 2007. It has now had two overlays put over top of it with the interlayer still intact. It bridges the joint where you do not know that the concrete pavement is underneath, because by offsetting the crack, it improves ride. So again, it's used but it's not for every pavement. It's a system that we only need to use in focused areas where we have cracking or limited solutions, and I'll show you those here in just a moment. The problem that we talk about is what you see on the right. You may have a crack when you take a core, and it's a very pronounced crack that may come through. And as you see the crack, if you look closely, you'll see the crack going all the way down with the ruler there, and it does come off the bottom where you would have had the joint. When we began to core where there's an interlayer, and here's an actual core on the left with the interlayer on the bottom, you can see the difference in color, the richness of the interlayer. Instead of having an aggregate structure that's filled with asphalt, you have an asphalt binder that we fill with aggregate, almost to a mastic level. By doing this, we have a crack dampening system that really significantly lays the cracks, also causes a waterproof barrier, but offsets the crack for up to about 3 feet. And that's the real interesting part of this interlayer, because we went out to core these projects and had to chase the crack across the pavement to even find where the joint was below. To give you an idea of the impressive value, and Tom had his, he gets to do his on a nice track where he has his back covered. Tom, I went out on Iowa, and while there's not a lot of traffic, there are cars that come through. So I went out and I had a person watching my back. I stood in the center line of the highway, and the picture on the left is looking on Iowa 9, which is one of the original ones, and when I was working at Coke at the time, and this is where the interlayer was down. It had I think at the time, a PG 5834 surface on top of it. And then I did a 180, literally turned around in the roadway where we had cut off the interlayer and had the typical treatment. And the only change between what's on the left and the right is the use of the interlayer. Can you tell a difference? You think it makes a difference on maintenance? I bet it would. Well, it made a big difference on ride too. And this is the power of using an asphalt dampening system or an interlayer. There's a lot of good products out there that have worked this through the years, and I use the Sammys myself, or the high polymer chip seals. But the interlayer is the only way that I'm talking about, that I'm going over today, to be able to get a 1-inch to up to about 1.25 inch crack dampening system in place with some level of structure that you can run a paver over it and have something that can be recycled if you want to take it up. But for the most part, it's perpetual. And as one person said, this is maybe a way to convert a concrete pavement to a perpetual pavement. At the end of my tenure, and the data that I had in 2006, I left in 2007, we saw about a 71% improvement in reflection cracking. They called it strata back in the day, but that was a high polymer performance design. Today we would call it a BMD design, and we'll go over that here in just a moment. That's using 98% reliable overlay with 100,000 plus fatigue cycle interlayer spec. That represents up to 18 projects built up to 4 years old at the time. So can we stop the reflective cracks? Well, I like to say no. I like to say no, and that was my typical answer till I saw data that really changed my mind on that. When you use the reflective crack relief interlayer, at University of Illinois found in their studies that it significantly reduced the movement of about up to 80%. But you have to have a surface that can still handle that remaining movement. So we can't put something that's ultra brittle on top, or the crack will come through as we would typically see. Now, we're going to slow it down, but what can we do to help remove that last 20%? I've seen SMA overlays over the interlayer that shown much promise with little to no cracks. And those were in the early projects. I do believe with the promise of high mod and what we're seeing today, high mod itself does an incredible job. You put it over the interlayer, I have no reason to believe that we couldn't nearly eliminate these cracks. That's not a cheap solution, but if you want to completely eliminate, again, assuming that you don't have excessive movement and slab rocking, we can do that. Otherwise, what you're doing with these systems is, again, you're delaying the problem. And Tom would probably correct me on this and said, Phil, but what about 30 years from now? Yeah, Tom, you're probably right. Something eventually is going to come through. So let's talk about the mix design. This is an ultra fine mixture. We're looking at something other with a 0.5 to 2% air voids. Minimum VMA 16, more typical is about 18. On the right, you see what would be considered a design gradation band. We're using a high amount of fines. So contractors out there have piles of fines. This is for you. Typically, we're using natural sand, manufacturing sand, and screenings, and to make this blend of materials. If I'm adjusting this, again, depending upon what climate you're in, if I'm looking up in the north where I may be using minus 34 binders, I'm going to start with this column on the left where I'm going to be in my cool climate. And these climate zones really, while I'm looking at what came out of the PG map software, it also overlays pretty well with what Corps of Engineers developed back in the 80s. In this case, maybe we use an ideal CT of the value that you see here. Now, that doesn't sound like a lot. That's 300 at 19C, but that's also designed at 3% air voids. Why in the world would we put something at 3% air voids? Well, that's what we're targeting in the field, not 7. And it is easy to compact when you get it into the field. Ideal CT works backwards. So lower air voids, which gives us a better pavement, unfortunately shows up as lower numbers in CT. If you were to look at this, and I put it down there just for the curious minds at the bottom, there's a note there that says that 300 CT at 3% air voids may look like about 750 CT at 7%. We do have a minimum rut resistance for the Hamburg wheel tracker at 4,000. And then depending upon what climate you're in, I bolded the center one there because that's where I'm in Kentucky. I sort of use that spec. If I move over to the right as we approach Alabama, down there at the track, guys, I would be probably looking at what you're recommending there once you get into that 22 and warmer climate to look at these values. It just happens to be that the CT of 25 aligns pretty well with what you're doing down there anyway. Okay, what have we hit before? Just to give you an idea of typical values that I've seen. This gives you an idea of how it works and on the CT values over different temperatures from 20 to 20 to 15 to 25C, different binders. In this case, I'm using a light polymer system. I'm using a double dose of aramid fiber. Why in the world why did I use fiber on this one? I don't have the polymer system I had back then. I needed tensile resistance, and it complements the system really well by giving me tensile strength. Bottom line is, whatever you can use to put in this system to get these values, you can do it. This is a performance-based design. The conventional mix is that little spot over there on the right, maybe at 153, and I'm telling you, 153 CT index is a good number. But it is possible to achieve these values that I'm showing here. Nathan, I don't know what you've achieved at NCAT, but I'm just gonna throw it down that I've gotten over 2100 at 20C on a CT index. So there's the challenge to you. Okay, see what you can do. Crack dampening system significantly delays the cracking. Impermeable, generic performance-based specs. It can be milled. I recommend to leave it in place. It's not going to crack. And it does heal with all the asphalt that's in it. Using standard HMA production and construction methods, locally available materials, this is something that the contractor can run through their plant easily. Quick construction, return to traffic, and it improves the ride. A little bit about site selection. I'm not going to spend a lot of time on this, but there is when you make this impermeable, you can trap moisture, so you have to pay attention to that. There's a less impermeable version that can be designed to open it up a bit. You lose a little bit of crack resistance, but not much. The overlay, depending upon the traffic level, these is what I've recommended over the years. This has been my safe zone. I have never seen an interlayer rut. And I want to keep it that way. And by doing studies and by using the performance testing in the laboratory and dialing it in, these are the values that I came up with years ago, depending upon the traffic level. 2024 project. This was a section of the turnpike. I'm going to move through these pretty quickly and then we'll be done. This was a section of the turnpike that we did in 2024. This was actually the test section that we put down, and this was an abandoned area, so we did not have any traffic on this one before they moved out to the main site. You get an idea when you put a roller on it. You would think something that may have 8.5 to 9% asphalt may move everywhere, but it is incredibly impressive underneath the roller. If you do get the asphalt way high on this one or way low, you do get a very unstable mixture. But in this case, you're compacting at about 1/8 of an inch per inch, and there's not a lot of room for it to go behind the paver. There is a little bit of flushing on this one that you see. They decided they wanted to vibrate this one, which is fine. You're going to bring the asphalt to the surface. This is not a riding surface. This is an interlayer. Some may ask, do you want to put tack over this? Absolutely. This project may have had enough free asphalt. We may not have needed the tack, but we still tacked it. This gives you a little bit of an idea. This was done up at New Enterprise. This is a quick video just summarizing everything that we just saw. Surface Tech supplied the fiber on this one that went up there. And this, again, just shows you what we had looked at before, going through the paver. There's another one I'm going to show you here in a moment where we had some hand working of the mixture. Normal process, the rolling that you've seen, and then I've got a picture here coming up of where it was actually put down on the interstate up there, and of course that looks good, and that's the team up there with Chris Forey and the folks at the Turnpike. Last year we went to a city street. This is a very favorable project for city streets because you're locked in with concrete. You can't do much with it. And this is a pretty ugly one. And what we're looking at here, we had to do special milling along the curb line to be able to key in the interlayer. And I'm just going to move straight to the video to summarize this because this, again, gives you an idea of the distresses, the tack before, what the fineness of the mixture. Again, the paving process, the hand working is over there on the right. You can hand work this one, move it around. You can imagine with the asphalt content, when it starts to cool, it will get gummy, but nothing unusual. Let me just move straight to the video on this one. Again, the pictures that we saw before. This, again, giving you the idea of what we were covering. Blythe Construction did this project over in Lexington, North Carolina, did a great job with this one. This one had a little higher asphalt content because we're working with the granite materials. Again, showing you the fineness of the mixture. No problem going through the paver. Very little sticking because, again, we're not using the high polymer on this one. We were using a 7622 on this one with a double dose of fiber. Again, this one had about 1.5% air voids, I believe. This shows you what it looks like with one pass the interlayer down before we put the other. Again, the hand working, no problem. The final interlayer, and then we go and there's the guys down there that we worked with on the project, and the guys over at Withers Ravenel with the consultant. Now they're putting the surface on and say hopefully it's ready to perform. With that, I've already covered what we talked about here on it being, but I'll hit it again, that we're going to significantly delay the reflective cracking. It's impermeable, performance-based spec. You can mill or leave it in place. Standard production, quick construction, improves ride. With that, that's all I have today, and I appreciate everyone for listening in, and always good to get to speak with Tom. Tom, impressive data. I had not seen your data down there before.
All right, so we're just going to wrap up, and then Tom is itching to get into some questions, and I agree the chat has been very lively. Thank you all for doing that. So just to summarize what Phil and Tom talked about, these interlayers, whether you use asphalt-based systems or special products designed for reflective crack prevention, they really make a great option whenever the existing site conditions or maybe budget constraints, whenever it restricts options. So maybe you can't mill as deep because it's just the city maintenance budget can't handle that. These treatments and technologies are great options for you. A couple things Tom talked about, being careful. You need to adjust the tack rates to prevent over softening or rutting, especially if you're using surface treatments like wrap or virgin chip seals. If you use too much tack or too much emulsion, you can actually end up over softening that layer, and then you end up getting rutting, not from whatever you're overlaying on top of it, but rutting from that interlayer itself. So you have to be careful about that. I loved Phil. I actually participated in the Q&A, and I asked you a question. I like your rutting spec, and I'm curious. But we'll get there in a minute. So quality control is super important. Some of the asphalt-based products, it's important there because some of these are not traditional kind of bread and butter asphalt mixes. Phil showed a picture of just a black layer that he talked about. Instead of adding binder to rocks, you're adding rocks to binder. So even in situations like that, QC is very important, but especially for the engineered products. The special designed interlayers. So if you are doing something like this, it's a big recommendation to call a technical rep before you try it for the first time. What you don't want to happen is have a bad experience with one of these technologies and then never use them again. That we've all seen that happen with all kinds of different technologies in our industry. I'm quoting Phil here. He said crack dampening systems or asphalt crack dampening systems. These things can significantly extend the life of overlays. He talked about improving ride and in general, but some of those pictures that Phil was showing of the milled surface, I think it was the second one when you were in a municipality, Phil. And I mean, it's like milling and maintenance 101. You don't chase cracking when you're milling, because otherwise sometimes you'll just keep going and going and going until you get to dirt. So sometimes you've got to have good maintenance options, or those cracks are going to come right back through. So these are great for those types of application, but be careful about trapping moisture. I actually remember the first time I ever had to deal with an interlayer, I was getting some questions, and I actually called Phil about putting OGI as an interlayer, but in a section that was milled, but the shoulder wasn't milled. And Phil said, don't do it, because you're creating a bathtub. And so no matter what you're doing, whether doing OGI, open graded interlayers, and then creating a bathtub, or like what Phil talked about, and I think Tom talked about it as well, where you're putting these asphalt membranes on top. You don't want to create pore pressure and end up trapping moisture and blistering from the bottom. And I actually added this one as well because of many of the chat discussion was around milling. And most of these products, if not all of them, can be conventionally milled. But if you have a really good interlayer that's doing its job, you may not even have to, mill that. And I thought that was a good point that Phil made. So with that, I want to thank our participants for logging on and getting the questions in the chat. I want to thank Travis for hosting this, but most importantly, I want to thank Tom and Phil for loaning us your time and your expertise today. So Travis is actually going to handle the Q&A today. But so Travis, I'm going to stop sharing and you can take it away.
Oh, shoot. All right. So a few questions that came up that were certainly ones that we want to make sure that we touch. So Nathan's already talked about the milling and so forth. And I think that in years past that there were some older versions of these interlayers that had a lot of trouble being milled up. And I personally saw some of those situations was we were trying to do like maybe a cold in place recycling, or I've seen it on a reconstruction of a military runway as well. Phil and Tom, do either one of you have experience with that change from when those interlayer materials were not as millable and not recyclable as they are now?
Yeah, Tom, you probably have a little broader. I can share a few of mine with you. I don't know if
Share away, Phil.
Oh, okay. Well, that was one of the reasons for with the development of this. It became really attractive when we were moving this forward at Coke because we were contractors were trying to figure out other solutions. Not that they greatly mind that the Petromat fabrics and the grids, and those are great products. But what are products that they could run through their plant that again using locally available materials, quick return to construction. So some of that became a problem with milling. Some of that became more of just speed of construction. When you do work with a few of these products, whether it may be a grid, you have to be aware where it's at. The fabric getting caught in a mill head. There was a product that was introduced, and it seemed like a great idea, but it was with I think using like a metal mesh, and that was one. That was a no-fly zone. You put that down and don't know where it's at. You catch that in a mill head. That's a problem. That was introduced about the time we started doing milling. And so in the process of milling and resurfacing came in early 2000s, all of that came in that had to be considered.
My only experience with the milling is what we did out at the track. I've seen them go down before, but I haven't been around for the milling up until this last go round when we took up the sections from the last two cycles.
Okay, great. And I do like Dan Clark from PennDOT has put his information out there, and I believe he also shared a document. Well, somebody shared a document in there that looked at this wrap as well and some of this experience. So that's great. Now, somebody asked about sharing the costs and what the costs are for these different interlayers there. And Tom and I both kind of responded in the chat that, the idea that it's difficult to share those kinds of costs across such a wide audience of people because the materials costs are different in different locations you go. Tom, can you share some of the thought process behind the sponsor asking that not to be published?
So it these are small runs. We did go ahead and get the typical bid values, and I pulled that together and I shared them back with Georgia DOT. But I was asked to leave that outside of the report because each situation is going to be unique. We certainly showed that the two geosynthetics work quite well, and PennDOT has some good experience as well. So for people looking to try those, you have to see what it's going to be in your market. As well as my one comment back was the first time you use them, work with the manufacturer. They're going to work with you and make sure you can roll it out cleanly, not have any issues with the paver. But yeah, I was asked not to share those costs, and I think that is right because just because I know what it was in Georgia doesn't mean it's going to apply nationally.
Yeah, I could share
Well, and then
those.
again, the work that's on the NCAT test track, those sections are extremely short. I mean, the full section is only 200 feet long. So there's certainly an economy of what it takes to mobilize the equipment, economy of scale if you're doing a full-size project there. So I think that's important to note on what the costs were at NCAT as well. Bill.
Yeah. Hey, they're free, right? No, that's what we wish.
The cracks
I
are
want to
free.
get two.
Yeah. Just stop up here and pick some up. They're roughly what I've worked with on this interlayer here. You definitely have an upgraded materials. It's probably doubled on the projects I've seen bid recently. You're anywhere from 190 to about 230 a mixed ton. Um,
Wow.
but when you put that into a life cycle, and I've run that over 30 years, anything that you get to last past the 10th year, if you get a crack delay past the 10th year, it's money in your pocket. And that's where you start to look, and your typical solution at the moment you hit 10.1 years, typically, depending on the values you put in, it tends to be money in your pocket with a traditional pavement structure. There is a cost savings as you can also everybody can see just from even the maintenance, which we're not even really accounting for a lot of maintenance in the life cycle cost piece of this with the crack sealing. That's just typical overlay replacement is what we look at.
Yeah. And again, you talked about the ton and how much the mixed ton is there, but remind us again how thick we're putting this material down there, Phil.
Oh, this one, yeah, this is 1 inch. Pennsylvania Turnpike was going to look at putting it down a little thicker up there on a job up to maybe about 1.25 inches, where you could even use it as a little bit of a leveling course to allow it to float between 3/4 to
Yeah.
yeah to about 1.25 inches. But usually an
So
inch, usually an inch.
yeah. So again, it being that thin, we can't think of that the same way as we would for a thicker overlay and what that ton actually
That
costs. So
that's a really good point. Yep.
yeah. Yeah. So, Phil, Nathan asked you a question here, and I want to make sure we get to it because we don't want to leave him with unanswered questions. But how did you come up with the 4,000 passes for the wheel tracking spec that you suggested?
Nathan, that's called experience, my friend.
Well, that's fine.
Yeah, no, it's in looking at that, I've had the opportunity to work with a Hamburg device since 1996 now, and sometimes I think our Hamburg limits, depending on where you're at in the U.S., can be a little harsh. For the interlayer, though, in general, this is it's a torture test, and for the most part, you would not want to use a number of 4,000 ever for a surface. Back in the day, I was using a super pave shear tester. There's probably very few on here that knows what that is, but that's how we actually dialed in the overlay thicknesses with the interlayer. We were just looking for a basic stability. Nathan, we need stiffness. So whether you're using an ideal RT, a hot IDT, um, I like the Hamburg because I get the repeated loading. The 4,000 is working, and it's matching up with my traditional knowledge from where I've been. Whether it's 4,000, 5,000, I'm not going to get in the whole 6, 7 thing, right? But 4,000, 5,000. Pick a number in there. It gives you a paving platform. It gives you something that you can run traffic over. We've run traffic over these for about 2 months. I wouldn't want to run it over longer than that. Matter of fact, I'd love to see them covered up within a couple of weeks. Let's not damage the interlayer. Let's get it covered up. So again, Nathan, we're making a great question. We're making a paving platform, and then your surface overlay does the rest.
Thanks.
Okay. Great. I saw a couple different questions that were out there that were asking about what the thickness of the overlay was. So Tom, can you tell us about the thickness of the overlay on the Georgia sections and even what you maybe know about the Arkansas sections? And then Phil, I'll tee you up for talking about at least what was on the Pennsylvania Turnpike project. So Tom, first.
So it was 2.5 inch mill down, and then with the interlayers, we pretty much put 2.5 right back. We brought it back to grade, and then for the various applications, they were all right around an inch. So it had 1.5 inch overlay on top of it. I just copied a link to the full report, which for anybody who wants to skim down, the reports are uh, each chapter is each section. They're very straightforward, but it gets into a lot more of the details of both the construction and the laydown.
Okay, great. Phil?
Yeah, the number that I used, and again, this was based upon using sort of modeling and performance tests back in the day. Anything under 3 million. So, when you're in city streets, 1.5 inches has worked well. We've had no problems. when you get in that 3 to 10 million or 10 to 30 million, that's when you go up to the 2.5 to 3 inches. Once you hit interstate level traffic, for the most part around here, Kansas areas, it'll be less, but when you get over the 30 million ESL threshold, the 3.5 inches is what I recommend. I believe on the Turnpike, the ones that we did up just uh, north of New York in Canada on 101, which is their main highway, and on the Turnpike on 76, I want to say we were at 3.5 inches over top, if not 4.
Okay, great. Great. Another question that came in is what tack products are you using with the different interlayers? So Phil, I'll let you go, and then Tom will want to hear about those that were used on the track as well.
Yeah, SS1H is fine, your typical tack, but you have got to let it break. You do not want to trap water. I've done it before, and
Preach, Phil.
yeah, let it break, man. And
Yeah.
but that my preference, if you can do it too, because you can get right back on it quickly, is just a straight 6422 is another option if you want to spray it that way. But yeah, SS1H typical tack operations, just fine.
Okay, great. Tom?
So we used a range of tacks. For the glass grid and the Petromat, it was a straight PG 6422. Application rate was for the glass grid 0.3 and for the Petromat 0.27 gallons per square yard. CRH, CRS 2-hour at 0.23 was used as our control. And under the
Mhm.
chip seal at that same rate, which was probably a little too high. And then for the asphalt rubber gap graded and the open graded interlayer, we use the Blackledge Ultra Fuse product. It's a trackless tack, and those were both applied at 0.25 gallons per square yard.
Cool. Okay, one
Travis,
last question I want to
hey,
make sure that we
hey
hit here.
Travis.
Phil, this is from our good friend Faustina that's out
Yeah,
there. What is the
okay.
DCT values that you obtain for the interlayer system, and have you tested the fiber system with the DCT as well?
Oh my goodness, straight to the heart. That's a good one.
Yeah.
Yes, we have. I'm trying to remember what it is for the fiber. We've I've lessened it from what we used to do. I've seen values of over 2,000 on a DCT, and that's down at like -10, -20. It's ridiculous, right? When you say numbers of 2,000 DCT 2,500, I believe if we're using a DCT and I could pick a number, I think 1,000 is probably where I'd want to be, and I'd have to look back at the climates to see where we would want to be on that, but. As far as temperature, but 1,000 is probably what I'd aim for. As a start,
Okay.
maybe 1,500.
Okay. Great. Great. Okay. Given that, we're going to go ahead and land this ship. Appreciate everybody being here, and Phil and Tom, thank you guys very much for all of the expertise and the information that you've shared with us there.
Thank you for
So
hosting.
we do always want to throw out there that if there's additional information that you want, that go into our test track website is a great place to go and find information clear back to the 2000 cycle on the test track, up through the 8th cycle that finished here a couple years ago. And you can find some summarization that's been done in the key track findings and so forth. So pavetrack.com is the direct to the track, or you can get there through ncat.us as well. Always like to throw out there, check out the training in your pockets. If you've not seen those, please do. Would love it if you'd subscribe. There's a QR code here on the screen, but if you just go to YouTube and search training in your pocket, that'll put you into our online videos. And there's a new product out there within that channel that's training in 90 seconds. So they're real quick little snippets of topics. Great way to share that information with folks who are trying to get into the laboratory and learn what they're doing, or sample aggregate in the field, or learn about the different equipment that's out there in our asphalt paving. We do want to give a little preview for next time. Our next webinar will be on May 21st, again at 10 a.m. Central Time, as always. And our next discussion is going to be about bond strength testing of our asphalt pavements. So again, Tom and Phil, thank you guys very much for being here and sharing what you have. Everybody else, we'll see you next month.